Hello everyone, I hope you're doing well. Today we explore differences between of category and of class in Python. But before we get started, I'd like to clarify these things with an example. Here is the classical iceberg metaphor, which is being used almost whenever we want to compare two different entities. Let's consider this example as a whole Revit software. The upper part is Revit user interface. What humans sees. This is the raw, honest, slightly chaotic truths. The lower part inside water, where the almost 80–90% of iceberg is hidden, is Revit database, is the engine. This is the curated reality. From the Revit UI, we expect of category related to the question, what do users call these things? This is the only user meaningful elements, matches schedules, categories, and filters. Instead of class is related to the question, what is this thing technically? It contains everything, includes internal helpers, stop elements, and invisible stuff. Now let's jump into Revit and Dynamo and see in Python what exactly I mean. Alright, the Revit version that I'm using is Revit 2026, and I'm building this tutorial on the Snowden Towers sample of Autodesk. Let's open Dynamo, and I have already imported my personal Python. The method I'm going to use is the filtered element collector for both of category and of class. First of all, let's try this for window element. For that, I'm going to name these two window underscore instances, and we say filtered elements filtered element collector. As an argument, we need to fill our document, our project, and here we say of category and we say built-in category, and usually it is OST underscore, in our case, Windows, and we collect all the instances, so we say where element is not element type. That's it. And let's have our inputs. To examine this, I'm going to count the instances. For that, I'm going to use get element count. All right. Now let's save and run. I spotted this one here. This should be caps lock where element is not element type. All right, let's run this. All right, now we have collected 106 instances of our windows. Now let's try another one. I'm going to grab the types here. We can name it win types. And almost all this line is correct, except this one here. We are going to say where element is element type. And now we can add this to our result list and search for the numbers. All right, save and run. Something is wrong. Let's see. Invalid syntax 3936. Win types. Interesting. This should be virgula because this is the list. All right. Now we've got 34 types, which is correct because with this type you can have more instances in your project. Now let's try this for a system family like a wall. I'm going to name this wall instances, and I'm going to copy this line. This is the same exactly, except this one, which we have to address our wall element, and we are going to collect all the instances. I'm going to add this to our list, output list, and count it. All right, let's save and run. Still we've got a problem here. Let's see. Of category, I think this should be walls. All right, now we have 1128 walls instances. And now let's try this for the wall types. I'm going to copy and paste this line, rename this to types. I have no idea what I've done, but let me correct this one, and let's retrieve our types. And we are going to count this. here is 69 type of our walls. So so far we use of category. All right, now I'm going to use the of class method. Let's see what happens. I'm going to use always the system family wall instances, and I'm going to name it like class. It doesn't matter, whatever you want to call it. Let's copy this line. Filtered element collector. Of course, here we are going to change this to class. And when you use of class, you don't need to use a built-in category as an argument. You have to insert just your category. In this case, this is walls, and where element is not element type. In our output list, I'm going to add this one. And let's see what happens, because we are going to see the differences between this line, which was based on of category, and of class. We expect to not see the exact same numbers of the elements here. Let's see what happens. Line 14, let's see. This is not walls. This should be a wall. All right, as you can see here, 1152 instances instead of 1128. That's because Revit counts all the walls inside Revit where almost is not the elements that can be schedulable, because this is getting all the instances of the categories that comes from .NET. So that's the difference between the of category and the of class method inside Python. Retrieving the elements. That should be, you should be really careful about these numbers. So when you see the of category, that's all the elements that can be schedulable. All right, and let's try another one here. I'm going to retrieve types. So retrieving types, of course we don't need this part. Let's add this to the output list. Here it is, our types. All right, and since we've gone so far here, let me try another things here that would be interesting. I'm going to rename it one. It doesn't matter for now. Let's say if we add this part to the to this line. Let's see what happens. I was looking for this one, is element type. Alright, as you can see here, we've got 0. That's because there are no wall types whose class is wall. So Revit is so honest and answers 0. So far we saw technically what happens when we use OfCategory and OfClass to retrieve elements. Now let's recap it. If you consider OfCategory an enclosure sign, OfClass would be a biological species, meaning that some enclosures contain multiple species. And now we understand why calling elements with OfCategory is lower than OfClass in numbers. Having said this, OfCategory method returns elements like have category equal to OST underscore walls or other categories, are visible, schedulable as walls, are not internal, analytical, or system artifacts. It answers the question or the code that the user would reasonably call a wall or other category. That's the example here. OfClass, meanwhile, returns elements that are instances of the .NET class, autodesk.revit.database.wall. Regardless of category filtering rules, including internal, generated, or non-schedulable walls. This method includes things like curtain wall backing elements, stacked wall internal layers, in place or system generated wall instances. And now here wall was an example, and this should be considered for the other categories. So that's it. I tried to learn this myself by this logic, and I hope it would be helpful for you as well.